Presenter again today is the one and only David Lair. He's going to build on the foundation laid last week and teach us all about how to properly wire a typical LMV3 system. So with that, David, it's all yours.
Morning, Steve. Thank you very much. Hello, everyone. I'm David Lair. I do training here at Elk Grove Village Training Center for the most part. I've been with SEC about 15 years. I've trained many of you at your office locations, your factory locations, and job sites as well. We have a technical support I'd like you to be aware of. The hours are Monday through Friday from 6:30 in the morning till 5 o'clock Chicago time. And we have a very extensive website, www.seccombustion.com. It's got a wealth of product information, data sheets, brochures, news, contact information for tech support and customer service. I highly recommend using our website. It's a wealth of knowledge. Today, we're going to do part 2, wiring on the LMV3. We have 4 more sessions to follow to complete the series on the LMV3 product. We're going to follow along with the LMV3 technical instruction manual. This is available online as a PDF, as a download anytime, even during the webinar. Or you can order one free of charge from tech support, customer service, or your sales force. And you may have already received one in preparation for the webinar today. Today, we're going to do LMV3 wiring. This presentation will cover 120 volt applications. You can contact sales, customer support, or tech support, and then we have 230 volt applications. Wiring will be different, part numbers will be different. The LMV3 is very flexible. Many wiring options are available based on your specific application of the LMV3 to your particular burner, be it new OEM or retrofits. Parameter settings can enable, disable, and even change the functions of some of the terminals on the LMV3. Section 3 covers the terminal numbers, which would be the plug group and pin, like 321, which would be air pressure switch. The type, whether it's an input or output, air pressure would be an input. The function, description, and the parameter. So that would be air pressure would be the function, and then the parameter number will be shown. And the rating of that particular terminal, how much voltage and amperage it can be used on it. Plus, we have an additional section on all the wiring diagrams in a familiar ladder format. LMV3, you see in front of you, the LMV3 chassis. The terminals are all keyed. That is, they have a specific shape so that the terminal will only fit in a specific socket that matches the key. So all the terminals that go on the LMV3 have keys. If you unplug them all, they can only be plugged back in a specific plug. It's the only one that will fit. This makes the wiring very easy and eliminates errors when servicing the LMV3. We also have green terminals. Those are tight pitch and those are low voltage. All the green terminals are low voltage connections. And then the white terminals have a larger pitch, and those are used for all the high voltage, the line voltage, 120 volts, or in some cases, 230 volts. Taking a look at the LMV3, we'll take a walk around on it. On the bottom left, you'll see I have highlighted the load terminal, X64. This is where the 420 milliamp would be put in to control the firing rate of the burner. Additionally, you could use Modbus or float bump, but this would be the load input terminal, 4 to 20 milliamp from a load controller, such as an RWF5 or any other load controller that you choose. Additionally, X74 would be where you would put in your variable frequency drive connections, or in the case of a PWM, your PWM connections. Next, taking a walk around the LMV3, we have fuel terminals. X54 is the fuel, and actually X53 is the air. These are the actuator terminals for the SQM33 servos that go onto the unit. They are very dependent on which one you plug them into. So the plugs are identical, so you have to make sure that you plug the fuel into X54 and the air into X53. There is no addressing or any such feature on the SQMs, so you have to be very careful when you plug them in. Next, we have X92. That would be a Modbus port. You can take the OCI module with the supply cable and plug it into X92, and now you add Modbus feature to the LMV3. That would be for local touchscreens, BMS, lead lag systems, whatever you'd like for the Modbus features. Next, going around the LMV3, we have X56, which would be an RJ11 port. Typically, we plug in the AZL through the TDC combo wiring, or you can connect your personal computer to this and you can configure, backup, and restore the LMV3 or do trending. On top, we have the white terminals. Those would be all the high voltage inputs and outputs to the LMV3. Same thing on the bottom. We have the white terminals. Those are the high voltage inputs and outputs as well on the LMV3. And finally, we have a fuse block highlighted there. It is a cartridge fuse, and there is an additional spare fuse in the cartridge right below it. So there's two fuses in there. One is used for the LMV3, one is stored there as a spare. Common terminals. The LMV3 has 10 protective earth terminals throughout the chassis, illustrated here in those locations. All of those terminals are connected together. When you connect protective earth to one of them, you connect to all of them. It just gives you a chance to land various equipment on there and take the protective earth terminal to various different pieces, so different places to tie it in. It's very common in Europe to use the LMV3 itself as the terminal strip. In the United States, we pretty much have a dedicated terminal strip where we often daisy chain multiple terminals. But the LMV3 provides these, so you could use the LMV3 as a direct termination. We also have several neutral terminals, the incoming neutral on the bottom, and then additional neutral terminals, such as connecting up for the fuel valves and the ignition and pilot. And we have 8 line voltage connections that have standing line voltage on them. These would be used to power like the gas switch, the air switch, stuff, so that the proof of closures, so that when the switches make, we have input going into the balance, which would be the white terminals, would be all the inputs and outputs on the LMV3. On the AGM60, we have a terminal on the side, X54, and it can take that cable, that AVG, from the fuel connection on the LMV336, the dual fuel. So an AGM60 is used whenever we're using dual fuels. You would plug that in from the fuel on the LMV3 to the side terminal on the AGM60. Then on the AGM60, you can connect up 2 different fuel terminals, one for fuel 0, one for fuel 1. And then the AGM will automatically switch SQM33 actuators depending on what fuel you're on. The purpose of the AGM is to do fuel change, to take the single fuel chassis LMV3 and direct it to field equipment that goes to 2 different fuels. Additionally, we have white plugs on there. These would be controlling the outputs to the individual fuel valves for fuel 0 and fuel 1, and the inputs, such as high and low pressure switches and proof of closures for fuel 0 and fuel 1. Again, the AGM60 takes all of the 2 different fuels, the field equipment, and diverts them to the LMV3, depending on which fuel is active at the moment. The LMV3, starting on page 4, has a chart that shows an extensive listing of every single terminal on the LMV3 and the AGM60. It includes a terminal number, in this case 321. This particular terminal has a type. It is programmable. Its function is the air pressure switch. And the parameters, like 211, gives you time setting to make the air pressure switch. 217 gives you time that you need to break the air pressure switch, so that when a fan starts, you can do your fan run-up time and give yourself 2 or 3 or 10 seconds, whatever it takes to make the air pressure switch. And then 217 is when you shut down the fan, gives you time to let the air pressure switch open, so you don't get a fault saying that there's a stuck air pressure switch on shutdown. 235 is an additional parameter, so you can use and decide what phases the air pressure would be measured in. Finally, on the right, we show a rating of 1.5 milliamp is the input. The air pressure switch is a very light load. It's 120 volts. And then you see the various amp ratings of all the terminals. Keep in mind that the main fuse is 6.3 amps. So the total on all of the inputs and outputs is a maximum of 5 amps. And then about 1.5 amps is left to run the LMV3 itself, which would be the servos and the load controls. So 5 amp total on all the inputs and outputs, but each individual terminal is rated higher than that. Here we see a quick overview on pages 12 and 13 in your manual. This would be a bird's eye view of all the 120 volt inputs on the left and all the 120 volt outputs on the right. Let's take a closer look. We'll start with the inputs. 120 volt inputs. Each one of them will give the terminal number. In this case, we see the safety loop is a series of terminals, bringing in the safety loop string from 342 to 341, connected to 332, and ultimately input to 331 is the final input of the safety loop string. In addition to the terminal numbers, we give a description. In this case, these terminals are dedicated to the safety loop, and maybe you can detail it and say that it has the burner flange part of the safety loop. This particular one has a parameter associated with it, number 215, and that's a repetition counter on the safety loop. So you can configure this input with the parameters, and that will be done. We will explain how the parameters affect the terminals when we do the parameter section next week. But this tells you when you're wiring it in, what parameters are needed to be configured so that the input acts the way you want for your particular application. When we go to the outputs, we have the same thing. We have the terminals here shown in red. 351 happens to be a fan terminal, a fan output terminal. In the description, we see that is in fact the blower motor starter output. And in this particular case, this parameter is not configurable. This will always be the fan output. It always engages, it always disengages as appropriate in the phases that it needs it for the particular fuel train that we've selected. The AGM60. The AGM60 is the dual fuel module. So you have an LMV36. In this case, 942 would be output to energize an input device. That would be an input going in there. So it would be, you would take power from 943, and then on fuel 0, in this particular case, we'd have a valve proving switch. That would go through the AGM60 and get presented to 942 as an input. And when we switch the AGM60 over to fuel 1, now we're on oil, and now we have a low oil pressure switch coming into the AGM, and the LMV3 on 942 sees the condition of the low pressure switch. In the same fashion, the LMV3 can be used for outputs, so that if the LMV3 energizes 821 as an output, the AGM60 takes it in, and then it outputs it to V1 gas in the case of fuel 0, or V1 oil in the case of fuel 1. And then 722 is the common neutral. So the AGM60 sorts out the inputs and outputs based on the fuel. It also directs the fuel actuator output terminal X54 goes to the AGM, and then the AGM sorts out whether it goes to fuel 0, in this case gas, or fuel 1, in this case oil. X54B is 0, X54A is fuel 1. The LMV3 can do a variable frequency drive. On the left, we'll see a variable frequency drive and the 3-phase blower and the terminals associated with it. In the center is the LMV3 terminals associated with the VFD, as well as descriptions on the right and all the associated parameters that are used to configure those terminals. When you use a variable frequency drive on an LMV3, you'll have to provide some additional equipment. The first thing you'll need is a speed sensor and a speed wheel. This comes in a kit together. The speed wheel you see is asymmetric. The speed sensor, this would give the RPM of the burner or blower back to the LMV3 so that the air can be monitored by the speed of the VFD. Next, we will need a relay. The LMV3 does 120 volt output. The VFD typically takes a 24 volt AC or DC input. So the 120 volt relay would dry out that contact and you would take 24 volts, in this case usually from the VFD, 24 volts DC, and take it through the CR1 and back, and this would start and stop the variable frequency drive when the LMV3 energizes and de-energizes the 120 volt terminals. Additionally, you'll have to add a power supply, 24 volt DC power supply. This would provide power for the speed sensor, and it also provides power to the LMV3 so that the 0 to 10 volt modulation signal can go to the VFD. The other air input option is a PWM, pulse width modulation. On the left, we see a typical pulse width modulation motor. 120 volts is presented to the motor at all times. And then you see the terminals for the control signals. LMV3 is again in the middle, and the description's on the right. You'll have to provide a power supply, 24 volt DC, to the LMV3 so that the LMV3 can generate an output PWM signal to control the speed of the motor. Additionally, that would power the board on there so that you can take an input back to the LMV3 from the tachometer. So again, like the VFD, we can monitor the speed of the air device for the combustion curve. Some PWM motors need power to the control board inside the PWM. If that's true, then that blue wire, you see the note, then you would provide power to the board inside the PWM as well. Some motors need it, some don't. It depends on which motor you select. If you're doing a single fuel LMV37, then the air servo, the air actuator, SQM33 air actuator, and the SQM33 fuel actuator would be connected to the LMV37. Air would go to X53, fuel would have to be plugged into X54. If you're going to run Modbus for a touchscreen, BMS, lead lag systems, you would have to add the OCI 412 module. This is where you would connect your building automation or any Modbus device, RS485. It comes with a cable provided with the OCI that would plug into the LMV3 X92, and the green plug would go into the OCI. Whenever you use a Modbus module, there's optical isolation to prevent damage from the building automation or any other interface device to the LMV3. So that optical isolation takes place in the OCI, and you're going to have to provide a power supply to the Modbus side of the module. This power can either be 24 volts DC, a typical 24 volt DC power supply, or in fact, it can actually be a 24 volt AC transformer. Either one will do. The OCI module will then sift off about 5 volts DC that it takes to drive the module and provide the 485 Modbus and the communication to the LMV3. As far as the flame scanners on the LMV3, this would show the most common use would be a QRA4, and there would be 2 wires going to X1006, and that would be a UV scanner. This would not be self-check. This would be a UV scanner to the LMV3. And the LMV3 additionally could take a flame rod in lieu of the UV scanner. Flame rods are inexpensive inputs. Every flame safeguard that I've ever seen has a flame rod input. It's a very simple input. The flame rod has a voltage on it that goes in, and it goes into the flame, and then you see the ground connection. The higher the voltage on the flame rod, the easier it is to detect the signal. Siemens provides an optional flame rod boost transformer. This takes line voltage off the LMV3 and provides about double the voltage to the flame rod so that the flame rod can pick up the signal. Again, this is an optional transformer that can be added to a flame rod application when you want to elevate the voltage on the flame rod. This concludes our wiring of the LMV3, simple and straightforward. Next week, we're going to do parameters and commissioning, the heart of the LMV3 system, and then we're going to do 3 more classes after that to finish the series. All right, I'll turn it over to questions and answers. Back to you, Steve.
All right. Well, thank you, Dave. That was some really good information and a very nice overview of the wiring for the LMV3. While you were presenting, we also had a few questions come in, so we're going to jump in and get some of these answered.
So it looks like the first question, Steve, is are all the common terminals connected internally, or do they have to be jumpered? And the answer would be no, they're all internally connected. So when you do connect to one protective earth, all the protective earth terminals inside the LMV are connected internally. And so you only have to provide one connection there from the line voltage coming in with the protective earth, and then anything you connect to any one of the protective earth terminals would be common. Any other questions, Steve?
Yeah, no, thank you. I was having a little technical difficulty over here. All right, another one we have here is, I see that the LMV3 can be used with a PWM motor. Did the LMV5 have the same capability?
Boy, I wish it did, but the LMV5 is about 5 years older than the LMV3. Around 2000, when the LMV5 was released, PWM was not very popular, and so it was not a feature that was added to the LMV5. The LMV3 is about 5 years younger, and so by the time the LMV3 hit the market, PWM was a popular option. So the PWM was added to the LMV3 offering. So the LMV3 can do PWM as well as the LMV7 series. The LMV5 cannot do PWM, only variable frequency drive.
Okay. Well, thanks for clearing that up. And then let's see, we got one more here. Do you need to run power wires and signal wires separate from one another?
Yes. As with all flame safeguards, light voltage such as the actuators, the fuel and air actuator, or the flame scanner, or the 4 to 20 milliamp load control signal, all of those signals must be run in a separate conduit from the 120 volt power wiring that would go to the LMV and air pressure switches and proof of closure switches, fuel valves, ignition transformers, as well as any of the 3-phase wiring must be separate. So just like any other flame safeguard, the LMV3 wiring must be kept separate from high voltage and low voltage, or you'll get interference.
Okay. Well, thank you for clearing those up, Dave. All right, well, it looks like that's all the time we have for today. So thank you guys again for joining us this morning. Stay safe, stay healthy, and have a great week.